Yeah, can we start? Yeah, good evening everyone. Good evening. Good evening everyone. Yeah, let's start now. Let's start. So topic is discrete mathematics. Topic is discrete mathematics. As I mentioned to you, first topic is logic. Right? First topic is logic. Second topic is graph theory. As I mentioned to you, third one is set theory, relations, functions. That is the third one. Right? Fourth one is lattices. Fifth one is group theory. Group theory. Sixth one is permutations and combinations. So these are the 6 topics. These are the 6 topics. Discrete mathematics. First topic is logic. Second topic is going to be graph theory. Third one is sets, relations, functions. Fourth one is lattices. Fifth one is group theory. Sixth one is permutations and combinations. Yeah. So yeah, let's before going, let me know if everything is okay. Before going, please let me know if everything is okay. Everyone respond. Before going further, let's respond, right? Let's respond, is everything is okay? Yeah, good evening Advait. Good evening Bharat. Advait, you can post in the group. Advait, you can post in the group. Advait, you can post in the group. Yeah, post in the group. We'll start now. We'll start now. Please post in the group. You also post. I will also post. Just give me 1 or 2 minutes so that everyone will come and we will start. Hello everyone. Today is the first class of discrete mathematics. So this is the syllabus. This is the syllabus. Today is the first class of discrete mathematics. This is the syllabus. Right, let's start. So I read already topics also. So see the topics. First logic chapter, second one is graph theory, third one is sets, relations, functions, fourth one is lattices, fifth one is group theory, sixth one is right permutations and combinations. So these are the topics. So whatever I am saying in the classroom, please study that properly. Whatever I am saying in the classroom, please follow it. Followed by in the group. You can solve the doubts, and you can solve the PYQs. And every weekend test will be there. You can write those also, right? And finally write the test series. You are going to get everything perfect. Just to be comfortable. Classes first, then followed by daily tests also there, weekly tests also there. Every day you can solve. If anyone post any doubt of discrete mathematics or completed subjects, you can solve those doubts in the group, then everything is fine. So discrete mathematics, first topic, logic. So let's write now logic. This is the first chapter. Logic is the first chapter, right? Logic is the first chapter, right? Let's start. Logic is the first chapter. Start this one. So I'm starting. Yeah, see the first thing. So this logic contain, there are two topics. First one, propositional logic. Second one, first order logic. Right? This logic chapter contain two topics: propositional logic, first order logic. There are two things. Now we are going to discuss propositional logic. We are going to discuss propositional logic. Right? Propositional logic we are going to discuss. First of all, what is proposition? What is proposition? Right? Let me try this one. What is proposition? A statement. I'm writing here. A statement. Follow properly. This will give approximately 2 to 4 marks. Minimum 2 marks. Maximum 4 marks will come. First of all, what is a proposition? A statement. A statement which is either true or false. A statement which is either true or false, but not both. But not both is known as proposition. Is known as proposition. Is known as a proposition. This is a proposition definition. Within few minutes, I will clarify. A statement which is either true or false. Either true or false. But not both. Remember, but not both. A statement which is either true or false, but not both, is known as proposition. So if you want, I will clarify little more clear. If you want, I will clarify little more clear. Let's see example. One example. One example. Examples I'm giving. First example. First example. Can you see this one? 2 plus 4 is equal to 6. It is a true. This statement is a true. So it is a proposition. It is a proposition. Next one, 2. 7 plus 10 is equal to actually 17. I am writing 20, which is false. So it is also a proposition. Next one, 3. X plus 10 is equal to x plus 10 is equal to 17. I think if x plus 10 is equal to 17, if x 17, other than 7, right? It is not 17. So it may be true, it may be false. It is not a proposition. A statement which is either true or false, but not both, is known as a proposition. 2 plus 4 is equal to 6, true proposition. 7 plus 10 is equal to 20, which is false proposition. X plus 10 is equal to 17. It may be true, it may be false, depending upon x value. If x value 7, 17. If x value 10, 20. X value 5, 15. It may be true, it may be false. It is not a proposition. It may be true, it may be false. Right? So I think this is a proposition definition. A statement which is either true or false, but not both, is known as a proposition. Please let me know if anyone having any objection. If anyone having any objection, please let me know. I'm expecting some doubts from you. Till now, do you have any objection? Till now, do you have any objection? Please let me know. A statement which is either true or false, but not both, is known as a proposition. So some examples also I given some examples. Let me know if anyone having any objection. Reddy sir, I have this doubt. Reddy sir, I have that doubt. If you have doubt, please let me know. Everyone, please let me know. I'm expecting answer from all of you. Advait, do you have any doubt? Advait, do you have any doubt? A statement which is either true or false, but not both, is known as a proposition. Let me know anyone having any objection. If you are okay with the proposition, I will proceed further. Now see the next story. Right? I think until now everyone is fine. Now see the next story. Proposition, I think everyone is comfortable. Now I am saying some other story. Can you listen that also? Let us assume 2 plus 4 is equal to 6. I think it is a true. Means it's a proposition. True, which is a proposition. Assume that it is a proposition P. Next one. 7 plus 15, which is equal to 7 plus 15, which is equal to 80. So this is false, that's okay. It is a false, that's okay. But remember, it is also a proposition. Assume it is a proposition Q. So first one is a proposition, assume P. Second one also a proposition, because 7 plus 15 is equal to 80, wrong. So second one is a statement which is false. So that is also a proposition. So this is one proposition. This is also one more proposition. Between these two propositions, I can keep R operator. I can keep AND operator. I can keep employees operator. I can keep P double employees Q. So I can keep negation P. Negation can be written like this also. Remember. So these connectivities. So between more than one proposition, if you use these operators, this is going to be compound statement, which is also called a compound proposition. Means to connect more than one proposition with the help of these operators, that is called a compound statement or compound proposition. It is one compound proposition. It is also one more compound proposition. It is also. So I am writing now compound proposition. Compound proposition. Right? So I think proposition, and two propositions, if you connect with the help of R operator, AND operator, employees operator, double employees operator, right? R operator. So these are known as compound proposition or compound statement. A statement which is either true or false, but not both, is called proposition. Between two proposition, if you keep some operator, that is called a compound proposition. So I hope this also clear. I hope this also clear. Compound proposition also clear. Proposition clear, compound proposition also clear. Now let's go a little more deeper. Let's go a little more deeper. I'm writing now. See this. This is one proposition. This is one proposition P. This is one more proposition Q. One proposition P, one more proposition is Q. Let's see. Everyone try to get everything in the class only. Try to get everything in the class only. PQ. Next one, PQ is fine, PQ is fine. And one more thing is, let's see this one, PQ. One more thing is PRQ. P and Q. Next one, P implies Q. Next one, P double implies Q. Next one, negation P. Next one, negation P RQ. Next one, negation Q implies negation P. Right? So yeah, let's try one by one. Let's try one by one. Let's try one by one. Compound statement I said to you. Now I have to say clearly what is AND operator, what is OR operator, what is implies, what is double implies. I have to say all the things clearly. I'm saying one by one. So PQ, let's see this one. Assume that it is a true. It may be true false. It may be false true. It may be false false. Yeah, careful everyone. So I'm writing one by one. Everyone know R operator. Anyone true. See this one. PRQ. Anyone true. Anyone true. Anyone true. So both are false. That's fine. Everyone know R operator. Everyone know R operator. Okay. Next one. What is the AND operator? Both should be true. Anyone fail. Anyone fail. Anyone fail. That is also everyone know. AND operator also everyone know. Next one. What about P implies Q? If anyone don't know P implies Q, see everyone. If anyone don't know P implies Q, please see this one. P implies Q means if the first one is true, second also should be true. P implies Q saying that if the first one is true, second should also be true. If not, then it is false. If the first one itself is fail, no need to talk. If the first one true, second should also be true. Then true. This is the very important one. This is very important. In the logic, this is the one which is running the entire show. Entire show in the logic run by this person. Right? In the logic, everything run by this only. Right? I think I'm keeping approximately 20 stars. Total logic run by P implies Q. Total logic run by P implies Q. P implies Q is very simple. If the first one true, second one should also be true. If not, false. See, if the first true, second should also be true. If not, false. Yes. If the first one true, second should also be true. Yes, true. If the first one itself is fail, no need to talk anything about the second one. So true only. First one fail, so true. First one fail, so true. Anyone having any objection, let me know. Implies is very important. If the first one true, second should also be true. If the first one is true, second should also be true. This is a very important one. First one true, second should also be true. If not, so it is a false statement. This is the very, very important. Remaining all are true. First one true, second should also be true. If not, false. Anyone having any objection, let me know. Employees is the one which will decide the entire story. Logic is completely based on the employees operator. Employees operator. Employees. I'm writing also. This is going to be employees. Or implies. P implies Q. P implies Q. Total logic is based on this particular one only. Total logic based on this particular one only. Some people are asking, sir, what about other things, sir? Let's see other things. So P double implies Q is very simple. If both true, true. See, both true, then true. Both are same, true. Both are same, true. Double employee is saying that if both are same, then true. Both are same, then true. If at all both are not same, false. Double employees are very simple. If both same, true. If both not same, not true. We may not use the double employees that much. We may not use the double employees that much. We may not use it. But anyhow, double employees is very simple. If both same, then true. If both same, then true. So I think a major one, I want to say employees is the major one. So I will underline only that. So this is the major one. Major one is this person. Careful. Major one is this person. Anyone having any objection, please let me know. This is the major one. Employees is major one. Double employees is very simple. Both same, true. Both same, true. Both same, true. Right? Next one. Some people are asking, sir, what is the negation, sir? Negation means if true there, false. False there, true. So what is the answer? P true. Then it will become false. If P true, negation P becomes false. If P true, negation P becomes false. Right? If P false, it will become true. P false, it will become true. That is also fine. I'm thinking until now everyone is comfortable. If you okay with this, let's go next one. Negation P RQ. Negation P RQ. Can you help me now? Negation P already here. Q already here. So can you help me now? Negation P RQ. Negation P RQ. You know R operator. Anyone true. So this one check. Yeah, true. And this one check. At least one true there, true. So, but not there. At least one true there, true. At least one true there, true. Let me know if anyone having any objection. So negation P RQ. Negation P RQ. Negation P is going to be, right? I think already here. This is the negation P. Negation P and RQ. Check. 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 R operator. So that is also okay. Until now, everyone is fine. Everyone fine until now. Until now, everyone is fine. Let me know if anyone feel that, sir, I am not getting this. Reddy, sir, I am not getting this. You just say to me, I will help you. Reddy, sir, I am not getting this. You just say to me, I will help you. Anyone? Okay, I think Advait, you identified or not? Advait, you identified or not? Advait, you identified or not? One interesting thing I want to say to you, Advait, you identified or not? I don't know. See this one. These two things are same. Check. Advait, you identified or not? I don't know. These two things are same. Some people are asking, when can I say a compound, right? When can I say two compound statements are true? When can I say two propositions are true? When can I say two propositions are true is if their truth table is same. If their truth table is same, then they both are same. Some students are asking, sir, when can I say two propositions are equal, sir? If their truth tables are same, then they both are same. Check. P implies Q, negation P or Q, they both are same. If you want, you can verify. If you want, you can verify. From this one, I want to convey from this particular point. I will write here. So first point I want to write to everyone. Please listen. P implies Q, which is equal to which is equal to negation P R Q. Please remember this. It's a very, very important one. Total logic, it will come again and again. Total logic, it will come again and again. P implies Q is equal to negation P R Q. Try to understand. Try to understand. And one more thing I want to say to you. Please listen this also. Please listen this also. Negation Q. So I will write here. It's a Q. Negation Q also writing because there is a need. Negation Q. Negation Q. So true means false. False means true. True means false. False means true. Now see this one. Negation P, negation Q implies negation P. Right? See this one. Negation Q implies negation P. You know implies. Implies means what? If the first one true, second one should also be true. Otherwise, it will become false. See this one. If the first one is false, no problem. If the first one is true, second also should be true. Where is the negation P here? If the first one is true, second one should also be true. If not, false. Next one. If the first one is true, no. That is the reason true. If the first one is true, second also should be true. Yes, true. What I mean to say is, right, Advait, remember, what I mean to say is, these three are equal. These three are equal. Let me write now. So P implies Q, which is equal to negation P R Q. One more thing, this is equal to Q implies P. Just reverse it. Then keep the negation to both. So this is the very, very important one. All these three are equal because their truth tables are equal. Can you check? Their truth table is equal. Two propositions are equal if their truth table is equal. So this is equal to. All three are same. All three will be same. If you want, I will give numbers also. Let me give some numbers. Some people are asking, sir, can you give some numbers? I will try to give the numbers. Let me give numbers. See this one? I think this may be number 1. This may be number 2. This may be number 3. Number 4. Number 5. Number 6. Number 7. So here which are equal is going to be third one equal to sixth one equal to seventh one. Third one equal to sixth one equal to seventh one. All three will be equal. Right? First one, second one. If anyone says, sir, color is creating some trouble, I will write another color. Nothing. I will write another color. Don't worry. Sir, this color is not happening properly. If anyone say, I will write another color. Just give me 1 minute. I will give another color. Yeah. So numbers, if you observe, I'm giving the white color numbers only. It may be number 1. It is a number 2. It is a number 3. It is a number 4. It is a number 5. It is the number 6. My required things only I am given the numbers. My required things only I given 1, 2, 3, 4, 5, 6. I think the third one, fifth one, sixth one equal. Third one, fifth one, sixth one equal. I written formula also. Just I want to convey this. It's a very, very important one. This statement is very, very important one. This is going to be very, very important. Please try to understand. It's very, very important. P implies Q is equal to negation P or Q, right? Negation Q implies negation P. So remember, here employees there. First, here also employees there, here also employees there. Sir, how they both will be equal? First to P implies Q. Reverse it first to. Negate, right? I think Q implies P. First to reverse it. I done. After reversing over, keep implies. After reverse over, please keep implies. Okay, that is also okay. That is also okay. Only for namesake, I am writing few more things. I'm writing few more things. Only for namesake, I'm writing few more things. Somehow I manage. Can you see this? Somehow I will manage. Can you see this? Somehow I will manage. Can you see this? See everyone? See everyone? Everyone see? Everyone see? Everyone see? Careful everyone. Everyone can see this. I think where I can write. So I will adjust little bit. I will adjust little bit. Don't worry. I will adjust little bit. I will give conclusion also. I will give conclusion also. Don't worry. I am adjusting. I am adjusting. See this one. It is a P implies Q. I am writing here Q implies P. Reverse. P implies Q. I am writing reverse. Q implies P. Let's see what will happen. Q implies P. True, true. So true. Next one. False, true. No problem. True. True, false. True, false. Everyone know Q implies P. If the first one is true, second should also be true, but not. So false. Next one, false, right? There is no problem. If you observe clearly, P implies Q cannot be equal to Q implies P. See, they both are not equal. P implies Q, Q implies P cannot be equal. Right? Let me write now. Second statement. P implies Q cannot be equal to Q implies P. If anyone thinking both are same, please remember. The reason is truth tables are not equal. See this. The reason is truth tables are not equal. If you want, I will give a number. 6 there, it may be 7. It may be 7. It may be some 4, 7 not same. 4 is P implies Q. 7 is Q implies P. They both are not same. 4 and 7 not same. P implies Q. Oh, sorry for that. P implies Q, right? P implies Q. I think so. We are comparing. P implies Q. 3 and 7. We are comparing 3 and 7. 3 and 7 not equal. We are comparing 3 and 7 not equal. And one more thing. If anyone having small doubt also, can you see this also? P double implies Q is equal to Q double implies P. What is the meaning of double implies? If both same, then true. PQ same, QP same, both are same. So that is the reason. So third, right? If you observe clearly, right? These are the observations. These are observations. These are the observations. What is the observation? Right? P single employee Q cannot be equal to Q single employee P. But double employees will work both the side. P double implies Q is equal to Q double implies P. These are the observations. Observation, if you see, first observation, very, very important. Second observation, most probably everyone know. Third observation also mostly everyone know. If you don't know, please let me know. P implies Q cannot be equal to Q implies P because truth tables are not equal. But P double implies Q is equal to Q double implies P. If you want, you can verify. Double implies. Only for namesake, I'm writing. P double implies Q available. Q double implies P, you can check. Q double implies P, you can check. If both same. If both same, then only true. Otherwise, not true. Right? See this one. Both same, so true. Both same, so true. So remaining both not same, false. If you want, you can check. They both are not equal. Which both not equal? So P double implies Q. See this one. P double implies Q. Q double implies P. These two are equal. But these two not equal. P single imply Q. Q single imply P. These two not equal. But these two equal. Double employees satisfy commutative property. This is called commutative property. Double employees will satisfy commutative property. Single employees don't satisfy commutative property. I hope everyone is fine. Right? So see this one. Double employees satisfy commutative property. Single employees don't satisfy commutative property. Advait, do you have any doubt? Advait, do you have any doubt? Let me know. Reddy sir, I have this doubt. You ask me, I will help. Until now, 3 observations I done. Until now, 3 observations I done. Until now, 3 observations. P implies Q is equal to negation PRQ is equal to negation Q implies negation P. That is one observation. One more observation. P single employee Q not equal to Q single employees P. But double will satisfy. Double will satisfy commutative property. Single employees don't satisfy commutative property. Okay. Until now, everything is fine. Until now, everything is fine. Now, one more important thing I am saying to you. Everyone listen. Everyone listen. One more important thing. One more important thing I am saying to you. Everyone listen. Everyone listen. So, P implies Q we have. We have P implies Q. We have Q implies P also. P implies Q we have. Q implies P also you have. Let's check here. P implies Q we have. Q implies P also we have. See, remember, these two are not equal. Everyone know. These two are not equal. Everyone know. P implies Q. Q implies P. Let's keep end operator. Let's keep end operator. Let's keep end operator. So let us assume that. See this one. Let us assume that P implies Q. Let us assume that P implies Q. First one, right? All the P implies Q values let me write. Because of lack of space, I am writing TFTT. This is TFTT. So let's go to Q implies P. Q implies P. TTFT. Do end operation. Do end operation. If you do end operation, see, I have to do end operation. If you do end operation, true, true. So true. Right? Next one. It is also true, true, true. So it is not true, true, false, true, true, false. What I mean to say is everyone observe. What I mean to say is, remember, this is equal to P double implies Q. This is equal to P double implies Q. So one more thing I am saying, one more thing I am writing here. Can you see this one? I think fourth statement. P double implies Q is equal to P implies Q, Q implies P, end operation. If you do that, they both are equal. This is the truth table for this. Assume that P implies Q. Assume P implies Q is this. Assume this is the P implies Q. I copied from above table. Q implies P also I copied from above table. If you do end operation, this one, which is exactly equal to P double implies Q, which is equal to the P double implies Q. So this is going to be equal. This is also one more important point, but a major one. This is the one which is very, very important because it is coming many places. It is coming many places. These all are important. These all 4 observations are important, okay? But first point is very, very important. Double employees is nothing but employees will work both the side. Double employees is nothing but, right? Single employee will work both the side and end operator. P implies Q not equal to Q implies P, but double employees, P double employee Q is equal to Q double employee P. But when you say P double employee Q, which is equal to P single employee Q and Q single employee P. These are the 4 observations. To say little bit clearly. I just drawn the table. No need to confuse. No need to confuse. If you have any doubt, you can ask me. Reddy sir, I have this doubt. If you have small doubt also, you ask me, I will help. The purpose of this one is I want to introduce what is AND operator, what is OR operator, what is single employees, what is double employees, what is the relation. Just I want to write. Today's class only just introduction purpose, just right, just saying the basics purpose. Basics purpose today's class. What is AND operator? What is OR operator? What is single employees? What is double employees? I want to explain. Other than this, nothing there. Little doubt also there. You let me know, I will help you. Observations also I written. Advait, let me know. Employees is very, very important. Employees is very, very important. 4 observations I written. So until now, if you observe clearly, I just said very small thing. What is a proposition? A statement which is either true or false, but not both. That is called a proposition. Next one. If two propositions, if you connect, that is called a compound proposition. More than one proposition, if you connect, that is called a compound proposition. That is also okay. Next one. Compound proposition. If you use OR operator, what is the behavior? If you use AND operator, what is the behavior? If you use employees, what is the behavior? If you use double employees, what is the behavior? What is the relation between all of them? This is the relation. These are the relations between all of them. Is it okay? Advait, is it okay? Can I move to next, Advait? These are the 4 observations. Try to understand. Bharat, you got it. Advait, you got it. If you people get, I will go to next. Right. So small doubt also. Reddy sir, I am not okay with this. See the truth table. 2 people are equal. If truth tables are equal, I will write here. See this one. 2 propositions equal. Let's write this note also. I'm writing the note. Note I am writing. 2 propositions. 2 propositions are equal if their truth tables are equal. Two propositions are equal if their truth tables are equal. Some students are asking, sir, how can I prove these 2 propositions are equal? If their truth tables are equal, they are equal. 2 propositions are said to be equal if their truth tables are equal. Sir, how you proved? Reddy sir, how you proved these 2 are equal? Reddy sir, how you proved these 2 are equal? Left one equal to right one. How you proved, sir? Right? Truth table of this one I constructed. Truth table of this one I constructed. Both are same. Reddy sir, how you proved that these 2 are not equal? Reddy sir, how you proved that these 2 are not equal? Truth table of this one I created. Truth table of this one also I created. I compared both. Both are not equal. So they are not equal. Reddy sir, how you concluded that this is right? This is equal. Truth table of this one you create. Truth table of this one you create. Both are equal. Sir, Reddy sir, how you know that these 3 people? How you know that these 3 people are equal? Truth table of these 3 people I created. I verified all the truth tables are same. You have to remember also. P implies Q is equal to negation P or Q. Or negation Q implies negation P. How you know two people are equal? How you know that? Draw the truth table, check. If both are equal. Both are not equal. How you know that? Second point, both are not equal. How you know that? Construct a truth table, compare. Anywhere they differ, oh, they are not equal. right? I think it's perfect. I think it's perfect. All observations also I written. All observations also I written. Now let me check. Let me check here. Right? So carefully everyone listen. Carefully everyone listen. 4 statements are over. 5th statement I'm writing. 5th statement. P implies Q. P implies Q. Right? See this one. P implies Q not equal to Q implies P. Already I written. P implies Q not equal to Q implies P. This is called as converse. This is called converse. Right? Next one, sixth one. This is called converse. So P implies Q, converse is Q implies P, but they both are not equal. They both are not equal, everyone know. This is called as converse of first one. If anyone asks you, for the first one, what is the second one? This is first one is you, this the second one is you. One is right, one is converse of 2. One is converse of 2. I will write properly. I will write properly so that you don't confuse. It is A here, it is B here. So remember, A is converse of B. This is called converse. Technical word is converse. Sometimes people will ask you, P implies Q, what is the converse? Q implies P. Are they equal? Not equal. P implies Q, what is the converse? Q implies P. Are they equal? No. They are not equal. Next one, some people are asking, sir, what about this? Sir, ready, sir, what about this? P implies Q not equal to negation P or negation Q. Right? So they are not equal. If you want, you can verify. They are not equal. Then A is inverse of B. This is called inverse. If you keep implies, that is called inverse. Right? If you keep implies, that right? If you keep the right, if you keep negation, that is called inverse. If you reverse it, that is called converse. Just remember the technical keywords. Just remember the technical keywords. What are the A converse? A converse B. If A is P implies Q, what is the B? Q implies P. Next one, P implies Q. What is the inverse? Just keep negations. That is going to be inverse. Right? That is going to be inverse. Right? Now let's go to next one. Seventh one. See this one also. P implies Q. P implies Q. First reverse it. Okay? First reverse it. Then keep negation also. So remember, this is called contrapositive. A is the contrapositive of B. It is a A assume, it is a B assume. It is a A assume, it is a B assume. Right? So A is contrapositive of B, but remember they both are equal. Technical words you have to remember. A is contrapositive of B. A is contrapositive of B. But remember, these two are equal. These two are equal. Right? So I think 4 observations. See, initially I written the 4 observation. I didn't mention the name. Now I mentioned the names. A, right? A converse is B. What is the meaning? Just reverse it. Next one. A inverse is B. Just to keep the negation. Next one. Right? A contrapositive is B. Just reverse also, keep negation also. Just keep reverse also, keep negation also. These 7 points all you remember. All these 7 points you remember. Let me know anyone having any objection. Otherwise, do you have any doubt? Just remember the names. Names remember. Names remember. P implies Q. What are the converse? Just reverse it. Q implies P, but they both are not equal. P implies Q. What is the inverse? Negation P implies negation Q, which is called inverse. They both are not equal. Next one. P implies Q. What are the contrapositive? Just reverse it. Keep negation. First to do converse, next to do inverse, then they both will be equal. Two times you done the opposite. First you reversed it, next you kept a negation. It became contrapositive, which is the seventh statement, which is nothing but first statement. First statement also same, but we didn't return the name. But in the seventh one, I kept the name also, contrapositive. They will ask in the examination, right? So A converse is what? A contrapositive is what? They will say some A. They will say some A. They will ask you A contrapositive what? Next one, A inverse what? A converse what? So like that they will ask you. These are the seven statements. These are the seven statements everyone have to remember. If you remember, right? Next class becomes very simple. Mathematical logic become very simple. I said the what is the statement. I said the first what is the proposition. I said afterwards what are the compound proposition, right? Next one, right? So how can I say two compound propositions are equal or not? Just construct a truth table. If two truth tables are equal, those two propositions are equal. Otherwise, they are not equal. So I drawn some table also. From there some observation. Almost like 7 observations. First observation is very, very important. Next one, P implies Q is equal to Q implies P. No, but P implies Q, right? Q implies P. What is the relation? One is converse to another one. Next one, P implies Q. Negation P implies negation Q. What is the relation? A is the inverse of B. P implies Q, negation Q implies negation P. What is the relation between them? It is a contrapositive. They both are contrapositive to each other, but they both are equal. They both are contrapositive to each other, but they both are equal. Small things I said. Small things I said. Small things I said. If you have little doubt also, let me know. If you have little doubt also, please let me know. Advait, is it okay? Advait, is it okay? Check one time. Is it okay? Fine. Right. Perfect now. Now see everyone. Now see everyone. I think you are really comfortable. Now what we can do, Advait, what we can do is, these all basics you people see one time. These all basics you people see one time, right? Tomorrow we will go to the actual topic. These all basics you see one time. In tomorrow's class, we will go little deeper, because everywhere these basics are needed. Just go through all these basics one time. Don't confuse a little bit also. One small doubt also there in the group you can post. One small doubt also there about today's class, right? You can post in the group. Right? I think there are some more basics are there, one or two. I will say those also, then we will disperse. Right? Small basics, few more are there. Let's see one time. It's a P, it's a Q. These are Boolean variables, are proposition variables. These are propositional variables. These are variable PQ. That's okay, right? PQ. Understand this also. PQ. These are propositional variables. Yeah, PQ. True. true, false, false, true, false, false. These are propositional variables. Maybe in the digital subject terminology, they are called Boolean variables. Here, because of the propositional logic, people used to say propositional variables. Yeah, you can say proposition also, right? They may say sometimes propositional variables. P is a one proposition or propositional variable. Q is a one proposition or propositional variable. That's okay. That's okay. Now see few basics. Few more basics are there. I will try once. What is negation P? P there. What is negation P? What is negation P? So P true, negation P is false. P true, negation P is false. P false, negation P is true. P false, negation P is true. That's okay. That's okay. Similar way, negation Q also I'm writing. So Q is true, negation Q false. Q is false, it is true. It is a true means false. False means true. Negation. Everyone know negation. Now understand. Everyone try to understand. Everyone try to understand. Everyone try to understand. So remember everyone. Remember everyone. It is a one proposition or propositional variable. This is a one proposition or a propositional variable. But this is called a propositional formula, which is called compound statement. This is called propositional formula. This is a propositional variable. These are variables. These are propositional variables, or you can say proposition. But here some operator you are using. This is a propositional formula. Propositional formula, which is called compound statement, which is called compound proposition. So let me write now. It may be useful some point of time. It may be useful some point of time. Propositional variable or proposition. Variable. Or simply you can write propositions. Propositional variables. These are going to be propositional formulas. These are propositional formulas. There are many propositional formulas. Let me write. Propositional formulas. Compound proposition, you can say compound proposition, you can say propositional formulas also. Propositional formulas also you can say, compound proposition also you can say. That is okay. There, that is a very small story. That is okay. Now come to the major point. Everyone try to understand. P R negation P. P and negation P. Understand everyone. P R negation P. P and negation P. So can you help you know? P true means negation P is false. Right? True false become true. Next one. P false means Q true, right? Negation P becomes false. So what I mean to say is, one is true means another one. It true means it is false. It is a false means it is true. When you do OR operator, all will become true. So remember, in a propositional formula or in the compound statement or compound proposition, in a propositional formula, all truth values are right, true. This is called tautology. In a given truth table, so this is the truth table. In a given truth table, right, all values are true. That is called tautology. So truth table of P R negation P. Truth table of P R negation P. All values are true. So this is called tautology. Now next one. If P false, negation P true, one true means another one false. These all will become false. These all will become false. Right? In a truth table, all are false. All are false. This is called a contradiction. This is called a contradiction. Please careful about the names. Please careful about the names. Yeah, we'll see that. We'll see that. In a truth table, all are true tautology. In a truth table, all are false contradiction. All are false. That is called a contradiction. Now, if you observe clearly, in a truth table, see this one. If you see this truth table, it is neither tautology nor contradiction. This is called as contingency. Contingency. In a truth table, right? In a truth table, all not true, all not false. A truth table which is neither a tautology nor contradiction. See, in this truth table, all are not true, means neither a tautology, all are not false also. All are not false also, nor contradiction. Nor contradiction. All are not true, so not tautology. All are not false, not a contradiction also. In the given truth table, all are not true, all are not false. In the given truth table, neither tautology nor contradiction is known as contingency. Is known as contingency. In the given truth table, all are not true, all are not false. Then the truth table is known as contingency. Next one. Let me say one more important thing. See, everyone listen. Everyone listen this basic point also. If you observe clearly, in this truth table, at least one true there. In this truth table, at least one true there. In this truth table, at least one true there. So remember, in the given truth table, at least, let me write now, at least one true. In the given truth table, at least one true. That is called satisfiable. That is called satisfiable. In the given truth table, at least one true. See, at least one true. At least one true. At least one true. Then I can say satisfiable. But remember, see, there is no true here. One true also not there. So remember, contradiction can never be a satisfiable. It cannot. Contradiction never be a satisfiable. But every tautology is a satisfiable. Every contingency is also satisfiable, because it is neither true. In the truth table, all are not true, all are not false. Neither tautology nor contradiction is known as a contingency, means at least one true there. It is satisfiable. Every contingency is satisfiable. Every tautology is satisfiable. Every contradiction is not satisfiable. What is satisfiable? First of all, at least one true. At least one true. So I will write those. Conditions also. I will write. See this one. In the given truth table, all true. In the given truth table, all true. Then it is called as tautology. 2. In the given truth table, all false. Contradiction. Names only. No need to confuse. Names only. One time you read. Nothing there here. One time you read. Nothing there here. Only names. In the given truth table, all true, tautology. In the given truth table, all false, contradiction. 3. Given truth table, which you can say compound proposition. Given truth table, neither tautology nor contradiction. Given truth table, neither tautology nor contradiction. Right? Given truth table, neither tautology nor contradiction. That is called contingency. Given truth table, neither tautology nor contradiction. That is called contingency. 4. Given truth table contain at least one true. Then it is known as satisfiable. That is the 4th point. Yeah, 5th point. Given truth table contain at least one true, satisfiable. So fifth one. Every tautology is satisfiable. 6th one. Every contingency is also satisfiable. Every contradiction is not satisfiable. Every tautology is satisfiable. Every contingency also satisfiable. Every contradiction is not satisfiable. Remember all these points. Advait, remember all. Shubhankar, remember all. In the given truth table, all are true. Tautology. All false, contradiction. Neither tautology nor contradiction, contingency. Given truth table contain at least one true, satisfiable. Every tautology is satisfiable. Every contingency is satisfiable. But every contradiction not satisfiable. So can you see all these points? Very useful things. Very useful things. Very tautology means satisfiable. Contingency is satisfiable. At least one true, satisfiable. All false, contradiction. All true, tautology. Advait, are you getting? Subhankar, are you getting? These are called propositional variables, which are also called as propositions. If you want, you can say propositions. Propositional variables, which are also called propositions. So this is going to be compound statement or proposition, right? Compound proposition. I'm repeating once again. This is called as compound proposition. Another name, propositional formula. Sometimes you will see propositional formula, which is also called as compound proposition. Compound proposition. Okay, fine. Now observe one more thing. I will just say that also, right? So with this we can stop it, right? See the one problem, one small problem. Observe clearly. Just one problem. How many how many propositional formulas, how many propositional formulas possible how many propositional formulas possible with two propositional variables. Assume those are PQ. How many propositional formulas possible with two propositional variables? Those are assumed that, right? PRQ. How many possible? I'm going to give answer. See everyone. I'm going to give answer. See everyone. How many propositional formulas possible with two propositional variables? Propositional variable means propositions. Propositional formulas means compound statements or compound propositions. How many possible? I'm going to give answer. Everyone see. PQ. Careful. PQ. It's a very interesting question. Everyone see this. How many propositional formulas possible with two propositional variables P and Q? I'm going to explain. Very simple. Very simple it is. True, false. False, true. False, false. Yeah. So this is the thing what he is asking. How many propositional formulas possible? How many propositional formulas possible with two propositional variables? So with two propositional variables, how many possibilities? Forget about how many propositional formulas. How many possibilities? I think every variable having two choices. Two variables, totally four choices. So this variable having two choices, this variable having two choices, overall possibilities are 2 square. Four possibilities are there. Four possibilities are there, which is nothing but four rows. Which is nothing but four rows. With the two propositional variables, four rows possible. How? Like this. With the two propositional variables, four rows possible. How? Right, like this. Every variable having two choices. Every variable having two choices. 2 into 2, totally four choices. Means four rows possible. Four rows possible. Understand everyone. Four rows possible. Understand everyone. Four rows possible. Now listen. Now listen. Four rows possible. That is fine. Listen. Four rows possible. That is fine. So here one propositional formula. See this one. Here one propositional formula is there. Right? Next one. Here one more propositional formula is there. Here one more propositional formula there. Like that, how many propositional formulas possible? Like that, how many propositional formulas possible? They are asking. Right? Now see this one. In the first two propositional formula, there may be chance that all may be true. In the second propositional formula, maybe all may be false. Maybe all may be false. In the next one, maybe true, false. Maybe true, false. Some people are asking, like that, how many possibles are? Ready, sir? Like that, how many possibles are? Very simple. Very simple. Like that, how many possibles are? See this one. Four rows possible. Careful, everyone. With the two propositional variables, with the two propositional, see this one, with the two propositional variable, because of every variable having two choices, four possibilities are there. Means four possibilities, which is nothing but four rows. Four rows possible. Remember, four rows possible. Every row having two choices. See, I think 4 rows in this area, right? This area, see, one 4 rows. First row having two choices, true or false. Second row also having two choices, true or false. Third row also having two choices, true or false. Fourth row also having two choices, true or false. So with the two propositional variables, see this one. With the two variables, 4 rows possible, means 4 possibilities. Every row having two choices. Every row having 4 rows are there. Every row having two choices, true or false. Totally 2 power 4 rows possible. 4 rows are there. Every row having two choices. 2 power 4. 2 power 4. 2 power 4 propositional formulas possible. First to find out how many how many rows possible. Next one, every row having two choices. See, every row, it may be true, it may be false. It may be true, it may be false. Right? Every row having two choices. Every row having two choices. You are already mentioned 4 rows are the every row having two choices. Totally 2 power 4. 16 propositional formulas possible. The answer for this one is 16. F16. F16. These many propositional formulas possible. With the two propositional variables, how many propositional formulas possible? First of all, find out how many rows possible. 4 rows possible. Next one, every row having two choices. It depending upon which formula. It may be negation, it may be AND operator, it may be OR operator, it may be negation, it may be AND operator, it may be OR operator, it may be employees. So like that, how many columns possible? You have 4 rows. Then how many columns possible? How many propositional formulas possible? Every row having two choices, true or false. So 2 power 4, 16 propositional formulas possible. So can you see the problem once again? How many propositional formulas possible with the two propositional variables? Two propositional variable, every variable having two choices. Right, so I think every variable having two choices, 2 into 2 4, totally 4 possibilities, means 4 rows. So 4 rows, every row you have two choices, it may be true, it may be false. Every row, it may be true, it may be false, it may be true. Like that, like the 2 power 4 propositional formulas possible, means 16 propositional formulas possible. I am thinking you are absolutely fine. Some people are asking, sir, same problem with 3 propositional variables. How many possible? Can you see one time? 3 propositional variables. How many propositional formulas possible? How many propositional formulas possible? I am doing now. One time listen. With the 3 propositional variable, how many propositional formulas possible? I am trying. 3 variables, right? 3 variables. P, Q, R. Everyone having two choices, true or false. Everyone having two choices, true or false. Totally 2 cube rows are possible. 2 cube rows possible. Next one, in every row you can keep true or false. So every row having two possibilities, right? 2 cube means 8 rows possible. 8 rows possible. So every row having two choices. So 2 power 8. 2 power 8 propositional formulas possible. 2 cube rows possible. Every row you can keep true or false, means two choices. Two choices. So this 2 came from here. This 8 came from here. right? Totally, if you observe clearly, 2 power 8, 256 propositional formulas possible. Fine, perfect. 3 propositional formula, 3 propositional variables. How many propositional formulas possible? 3 variables. Okay, every variable having 2 choices, true or false, right? So 2 cube, totally 8 rows possible. But every row you can keep true or false, right? So I think 2 into 2 into 2 into 8 times 2 power 8. 256 propositional formulas possible. Advait, are you comfortable? Advait, are you comfortable? Advait, are you comfortable? Subhankar, are you comfortable? Subhankar, are you comfortable? Everyone give answer. Everyone give answer. Are you comfortable? This is one of the nice question. It may be tough. It may be tough. Right? It may be tough. How many propositional formulas possible with 2 propositional variables P and Q? Okay. So, right, 2 propositional variable P and Q. Every variable, you can write true also, you can write false also. So 2 possibilities. P 2 possibilities, Q 2 possibilities. Totally 2 into 2, 4 possibilities. Means 4 rows. 4 possibilities means 4 rows. But every row, what you can write? I may write true or I may write false. So 4 rows. Every row, 2 possibilities. 2 variables, then 4 rows means 4 possibilities are there. Every row having 2 possibilities, true or false. Right? So here, true or false, 2 possibilities. 4 rows. So this 4 came from here. This 2 came from here. Same story. So 2 power 4 propositional formulas possible 60. To get the more clarity, I given one more. 3 propositional variables. How many propositional formulas? 256. Some people are asking, sir, can you generalize for n propositional variable? Let's see. N propositional variables. N propositional variables. N propositional variables. Okay, fine. That's okay. Then n propositional variable, every variable having 2 choices. 2, 2, 2, 2. N. 2 power n rows possible. Possible. Next one. 2 power n rows possible. Okay. 2 power n rows possible. Okay. Every row having 2 choices. Every row having 2 choices. True or false. 2 choices. So finally, 2 power n. This is came from here. This is came from here. So answer is 2 power n propositional formulas. Propositional formulas are compound propositions possible. Compound propositions possible. 2 power n propositional formulas possible are compound propositions possible. I think you are okay. I think you are okay. I think you are okay. Let me know your point. Let me know if you have any doubt. Yeah. Advait, can we meet in the next class? Advait, can we meet in the next class? It's one of the tough problem. It is one of the tough problem. You got this also means I think you can handle anything. It is one of the tough problem. You got this one means you will get, I think, most of the things you can handle. You got this one means most of the things you can handle. It's one of the tough problem. So all the basics I done. All the basics I done. From here logic is started. From here logic is started. Just go through it one time. Just go through it one time. Lastly, I given one nice problem. I think you may get the clarity. Little doubt also there. In the group you can post. Little doubt also there. In the group you can post. Right? Fine. Thank you. Thanks everyone. See you in the next class. Thanks everyone. See you in the next class. Fine. Advait, if you have doubt, you can ask in the group. Subhankar, if you have any doubt, you can post in the group. Right? Bhushan, if you have any doubt, you can post in the group. Right? Fine. Those people who want to prepare GATE 2026 or 27, comfortably you can join in this batch. Comfortably you can join in this batch. Only one class over, only one class. Today's class is the first class. You can see all of them. You can see all of them one time. Today's class is the first class. You can see the total class one time. You can join in from the tomorrow's onwards. Thank you. Good night.